to the review session of Bhopal Sir's Career Point. This is a video for the student of class 11 in practice series for the internal examinations as per the modified question pattern of CHSE Odisha in the chapter Thermodynamics. प्रथम आम जाना ये एग्जामिनेशन 20 मार्क्स क्वेश्चन आसे या टाइम ड्यूरेशन थाए 45 मिनिट्स ये 45 मिनिट्स को आम कि परीक्षा हमें मैनेज करिया विषय देखा टाइम डिस्ट्रीब्यूशन क्वेश्चन पेपर रीडिंग एंड अंडरस्टैंडिंग 5 मिनिट्स आम 5 मिनिट भितर क्वेश्चन पेपर को पढ़ा और बुझा केमुटी करवा बोली स्थिरीकृत करवा ग्रुप ए रे 5टी प्रश्न को 7.5 मिनिट्स ग्रुप बी रे 2टी प्रश्न 8 मिनिट्स ग्रुप सी रे 2टी प्रश्न 12 मिनिट एवं ग्रुप डी रे गोटे प्रश्न उत्तर लिखापी आम 12.5 मिनिट नेबा एबे 4 प्रकार ग्रुप वेलकम टू ऑल ऑफ यू टू द ग्रुप ई ऑफ दिस क्वेश्चन हियर ऑल द क्वेश्चंस आर कंपल्सरी कवरिंग ओनली द मल्टीपल चॉइस क्वेश्चंस each questions require not more than 1.5 minutes to write the answer प्रत्येक प्रश्न को 1.5 मिनिट्स करी 7.5 मिनिट्स रे एई 5टी एमसीक्यू प्रश्न उत्तर आमको 5 मार्क पाई करबा को पड़िबो लेट अस कम फॉर द क्वेश्चन नंबर 1 व्हेन एग इज बॉइल्ड द एंट्रोपी डेज जते बेले आमे एग को बॉयल करू सेते बेले एंट्रोपी कोन हुए ऑप्शन ए इंक्रीजेस ऑप्शन बी डिक्रीजेस ऑप्शन सी remain same option D all of these try what will be the correct answer for this when egg is boiled the change in entropy always depends upon the change in the state when egg is boiled the egg is converted from liquid to solid state is the entropy of the gas is maximum and minimum in solids or entropy of the liquid is more than solids. So as when egg is boiled, it changes from liquid to solid, the entropy decreases. So option B is the correct answer. Let us come for the question number 2. Out of the following, which is an extensive property? निम्नलिखित मध्य केउंटी एक्सटेंसिव प्रॉपर्टी अटे ऑप्शन ए इंटरनल एनर्जी ऑप्शन बी एंथैल्पी option C entropy option D all of these what is an extensive property the property whose value depends upon the amount of substance are called extensive properties जो गुड के अमाउंट ऑफ सब्सटेंस ऊपर डिपेंड करे से गुड के एक्सटेंसिव प्रॉपर्टी आमु जो गुड के इंडिपेंडेंट थाए एमे ताको इंटेंसिव प्रॉपर्टी बोली कहि थाओ एटी इंटरनल एनर्जी डिपेंड्स अपॉन द अमाउंट ऑफ सब्सटेंस इट इज एन एक्सटेंसिव प्रॉपर्टी Enthalpy also depends upon the amount of substance present in the system. It is also an extensive property. Entropy is also depends upon the amount of substance. So, the correct answer is option D. That is all of these. Now, let us come for the next question. Question number 3. Out of the following, which is a path function? निम्नलिखित मध्यरु केउंटी गोटे path function अटे? Option A, internal energy. Option B, enthalpy. Option C entropy option D none of these which will be the correct answer केउंटी path function हमें path function कोन बुझिबा the properties of the system which value does not depend upon the initial and the final state it depends upon the path followed by the system it's called a path function and the properties which depends only on the initial and the final state are called intensive properties. State functions. Internal energy depends upon the initial and the final state, independent on the path. So it is not a path function. Enthalpy depends upon the initial and the final state, independent on the path. So it is also not a path function. Entropy depends upon the initial and the final state of the system and independent on the path followed by the system. So it is also not a path function. So option D there is none of these. एमानक मध्यरु कोनोसीटी path function नुई ए तीनोटी जाको A B C इंटरएनर्जी, इंटरनल एनर्जी, एंथैल्पी, एंट्रोपी ये माने समस्त स्टेट फंक्शन। ଏବେ ନଜର ପକେଇବା ନେକ୍ସଟ କ୍ୱେଶ୍ଚନ ନମ୍ବର 4. What is the relationship between change in internal energy and enthalpy for the Haber synthesis of ammonia? Option A, delta is equal to delta I. Option B, delta is less than delta I. Option C, delta is greater than delta I. And option D, all of these. Which will be the correct answer? Haber synthesis of ammonia. N2 plus 3H2 gives us ammonia. Here Np is equal to 2 and Nr is equal to 4. So delta Ng is Np minus Nr, that is 2 minus 4, that is equal to minus 2. Delta I is equal to delta I plus delta Ng at T. So here delta I is equal to delta I minus 2 at T. Delta H is equal to delta I minus 2 at T. So which is greater? Delta I is more. Delta H is less. So option B is the correct answer. That is delta H is less than delta I. Let us come for the next question and the last question of group A. Question number 5. When cloud condenses to rain, the entropy dash. ଯେତେବେଳେ ବାଦଲ ଘନୀଭୂତ ହୋଇ ବର୍ଷାରେ ପରିଣତ ହୁଏ ଏଣ୍ଟ୍ରୋପି କ'ଣ ହୁଏ? ଅପସନ୍ ଏ increases, option B decreases, option C remains same, option D all of these. Which will be the correct answer? When cloud condenses to rain, क्लाउड टी गैसियस फॉर्म में थिला, कंडेंस से रेन को आसिला अर्थात लिक्विड स्टेट को आसिला, एंट्रोपी डिक्रीज कला कारण एंट्रोपी मैक्सिमम इन गैसियस स्टेट. So entropy decreases. That is option B is the correct answer. When cloud condenses to rain, the entropy decreases. We'll come to all of you to the group B, which is the 2 marks, which contains only 2 marks questions. Here 2 short questions to be answered out of 4. Each question requires not more than 4 minutes to write the answer. ଏଇଭଳି ପ୍ରତ୍ୟେକ ପ୍ରଶ୍ନକୁ 2 ମିନିଟ୍ କରି 4 ମିନିଟ୍ କରି ଆମେ 4 ମାର୍କ ପାଇଁ ସମୁଦାୟ 8 ମିନିଟ୍ ଭିତରେ ଗ୍ରୁପ୍ ବିରେ 2ଟି ପ୍ରଶ୍ନ ଉତ୍ତର ଲେଖିବାକୁ ପଡ଼ିବ. ଏବେ ନଜର ପକାଇବା କ୍ୱେଶ୍ଚନ ନମ୍ବର 1 ଅଫ୍ ଗ୍ରୁପ୍ ବି. Derive the relationship between change in enthalpy and internal energy. Delta H ଆଉ delta I ଭିତରେ ରିଲେସନକୁ ଡେରାଇଭ୍ କରିବା. Now, what is H? We know that H is equal to E plus PV. So delta H is equal to delta E plus P delta V. एक କଥା हम already determine କରି ସାରିଛୁ. According to the gas equation, PV is equal to nRT, implies for reactants PVR is equal to nRT, and for products PVP is equal to nPRT. Now PVP minus PVR is equal to nPRT minus nRT, which is equal to nP minus nRT. I mean the P common is P into VP minus VR is equal to nP minus nRT, implies P delta V is equal to delta nRT. Thus delta H is equal to delta E plus delta Ng RT. By putting value of P delta V in equation A, we get delta Ng. Now what is delta Ng? The delta Ng is equal to delta Ng products minus delta Ng reactants. By putting the equation B in equation A, we get delta H is equal to delta E plus delta Ng RT. This is the relationship between delta H and delta E. By getting the value of delta G, we can find out whether delta H is equal to delta I, or delta H is less than delta I, or delta H is greater than delta I. If delta Ng is equal to 0, then delta H is equal to delta I. If delta Ng is greater than 0, delta I is greater than delta I. If delta Ng is less than 0, delta H is less than delta I. This is the relationship between delta H and delta I. Now come to the second question of group B. State and explain first law of thermodynamics. Or the first law of thermodynamics statement of explanation কথা দেখিবা. প্রথমে statement কথা দেখিবা. The first law of thermodynamics is simply the law of conservation of energy and can be expressed in different forms. Energy can neither be created nor it be destroyed, but it changes from one form to another form. Again, total energy of the universe remains constant. Mathematical expression: when work is done by the system due to expansion, the gas loses internal energy in the form of work, then the equation can be written as delta E is equal to Q minus W, implies Q is equal to delta E plus W, implies Q is equal to delta E plus V delta V. Now, come for the third question of group B. Calculate the standard enthalpy for the reaction H2 plus Br2 gives you 2HBr. Given that the bond energy of HH, bromine, and HBr is 435, 192, and 368 kilojoule respectively. Now, let us come for the solution. If the given equation is written in the form of bond structure, then HH plus Br gives us 2HBr. Delta H is equal to sum of bond energy of the reactants minus sum of the bond energy of the products. Reactor ପାଖରେ ଗୋଟେ HH ଅଛି ଆଉ ଗୋଟେ ବ୍ରୋମିନ୍ ଅଛି, ତାଙ୍କ bond energy को plus କରିଦେବା minus twice of bond energy of HBr. Putting the value of the given bond energy, the value is calculated to be minus 109 kilojoule per mole. Thus, this reaction is an exothermic process as the delta H is found to be negative. What is calorific value? Write down its significance. This is the fourth question of group B. ଆମେ calorific value କହିଲେ କ'ଣ ବୁଝିବା? Calorific value means the amount of energy produced when one gram of a substance, food or fuel, is completely oxidized or burned is called its calorific value. ଗୋଟେ food ବା 1 ग्राम food ବା fuel को completely burn ବା oxidize कले ଯେତିକି amount of energy मिले ଆମେ ତାକୁ ତାର calorific value ବୋଲି କହିଥାଉ. Example: methane burns in oxygen to give CO2 and water with the evolution of 890.3 kilojoule of energy. Here enthalpy of combustion is equal to minus 890.3 kilojoule per mole. Carbon burns in oxygen to give carbon dioxide with the evolution of 393.5 kilojoule. Here delta Hc is equal to minus 393.5 kilojoule per mole. Significance: the heat of combustion value, that is caloric value, is responsible for rating the food or fuel. Now we'll come to all of you to the group C of this question paper, which contains 3 marks questions. Here 2 questions is to be answered out of 4. Each question require not more than 6 minutes to write the answer. এইଭଳି 2ଟି ପ୍ରଶ୍ନ ଉତ୍ତର ପ୍ରତ୍ୟେକକୁ 6 ମିନିଟ୍ କରି ଆମକୁ 12 ମିନିଟ୍ ଭିତରେ ଗ୍ରୁପ ସି ର ଉତ୍ତର 6 ମାର୍କ ପାଇଁ ଦେବାକୁ ପଡ଼ିବ. ଏବେ ନଜର ପକେଇବା question number 1 of group C. Write a note on endothermic process or briefly describe the endothermic reaction. ଏବେ ଆମେ endothermic reaction କାହାକୁ କହିବା? endothermic reaction ଯାହାକୁ ଆମେ ଓଡ଼ିଆରେ କ'ଣ ତାପ ଶୋଷୀ ପ୍ରତିକ୍ରିୟା ବୋଲି କହିଥାଉ. The reactions which are accompanied by the absorption of heat energy are called endothermic reactions. The compounds formed by the endothermic reaction are called endothermic compounds. The endothermic compounds contain more energy than the reactants. ଏବେ endothermic reaction को ଆମେ examples हिसाब नबा. Endothermic reactions are represented as follows: A plus B plus Q kilocalorie gives you C plus D, or in other words we can say A plus B gives us C plus D, where delta H is equal to plus Q kilocalorie. In endothermic reaction, enthalpy of the products Hp is more than enthalpy of the reactants Hr. So delta H is equal to Hp minus Hr is always positive in case of endothermic reaction. Hence, endothermic reaction reactants have less energy than the products. Let us have a look in the graphical representation of endothermic reactions. Here, the energy of the reactants is less than the energy of the products. The Ep is greater than Er, or we may say Er is less than Ep. So delta E, that is Ep minus Er, is positive in case of endothermic reactions. Now, let us Take the example of endothermic reactions. Two carbon bonds reacts with hydrogen to give C2H2 acetylene. Delta H value is 240 kilocalorie. Half of N2 combines with half of O2 to give nitric oxide NO. Here also delta H is positive, that is 20 kilocalorie. Carbon reacts with sulfur to give carbon disulfide. Delta H is equal to plus 22 kilocalorie. Now come for the second question of group C. What is enthalpy of neutralization? With a suitable example, describe the neutralization of strong acid and strong base. ଏବେ ତ ଆମେ ଏଠି କ'ଣ ଆମେ ପ୍ରଥମେ ଲେଖିବାକୁ ପଡ଼ିବ ଏନ୍ଥାଲପି ନ୍ୟୁଟ୍ରାଲାଇଜେସନ୍ କହିଲେ ଆମେ କ'ଣ ବୁଝୁ ଗୋଟେ ସୁଇଟେବଲ୍ ଏକ୍ଜାମ୍ପଲ୍ ଦେଇ ଆମେ ତାକୁ ଡିସ୍କ୍ରାଇବ୍ କରିବାକୁ ପଡ଼ିବ ହ୍ୱାଟ୍ ଡୁ ମିନ୍ ବାଇ ଏନ୍ଥାଲପି ଅଫ୍ ନ୍ୟୁଟ୍ରାଲାଇଜେସନ୍ the amount of heat evolved when 1 gram equivalent of acid is completely neutralized by 1 gram equivalent of a base in dilute aqueous solution is called enthalpy of neutralization. 1 gram equivalent of acid, 1 gram equivalent of base सहित न्यूट्रालाइज सल्ट एंड वाटर दब आम ताको एंथैल्पी ऑफ न्यूट्रलाइजेशन बोली कही था। ई न्यूट्रलाइजेशन विभिन्न प्रकार it is denoted by the symbol delta Hn. The value of delta Hn is always negative as heat is evolved in the neutralization reaction. For strong acid, strong base neutralization. Strong acid, strong base neutralization the enthalpy of neutralization of all strong acids by the strong bases is always equal to minus 57.1 kilojoule, irrespective of the nature of the acid or base. कौन प्रकार एसिड बा बेस निया मतलब ना स्ट्रंग एसिड स्ट्रंग बेस निया तार एंथैल्पी न्यूट्रलाइजेशन टी minus 57.1 kilojule हम. For example, let us consider the neutralization of strong acid HCl and strong base NaOH. HCl, that is H plus and Cl minus, NaOH, that is Na plus and OH minus. After neutralization it will give us Na plus aqueous plus Cl minus aqueous plus water. Here the delta Hn value is equal to minus 57.1 kilojoule. By cancelling the common ions, that is Na plus and Cl minus, the above equation can be written as S plus aqueous plus OH minus aqueous gives water liquid. Delta Hn value is minus 57.1 kilojoule. Now, let us come to the third question of group C. Write in Newton enthalpy of fusion. Enthalpy of fusion कहले हमें कौन बुझिबो? The enthalpy change or the amount of heat absorbed when 1 mole of a solid substance is converted into its liquid state at its melting point is called heat of fusion or molar enthalpy of fusion. It is represented by the symbol delta H fuse. Its value is always positive because it is an endothermic process. When 1 mole of ice melts at 0 degrees Celsius, the heat absorbed is 6.02 kilojoule. Thus, H2O solid, that is ice, whenever converted to H2O liquid, water, the enthalpy of fusion is 6.02 kilojoule per mole. Noted below, I mean, delta H fusion is equal to molar mass into latent heat of fusion per gram. Delta H fuse, enthalpy of fusion value, gives the idea about the intermolecular force operating in solids. Larger the intermolecular forces, larger will be the enthalpy of fusion, that is delta H fuse value. Enthalpy of fusion values are low for molecular solids due to presence of weak van der Waals forces. But delta H enthalpy of fusion values are high for ionic solids due to the presence of strong electrostatic force of attraction between the oppositely charged ions. Now, let us come to the fourth question of this group C. Calculate the enthalpy of formation of ethane from the following data. Carbon bonds in oxygen to give CO2. Enthalpy change is minus 393.5 kilojoule. Again, hydrogen bonds in oxygen to give water. Enthalpy of change is minus 285.8 kilojoule. In C2H, that is ethane bonds with oxygen to give CO2 and water. Enthalpy change is minus 1560 kilojoule. Now, आमको अगर इक्वल इक्वेशन काढ़िया को पड़िबो तापर गिवन इक्वेशन को नहीं ऑपरेशन करी आमको रिक्वायर्ड इक्वेशन सॉल्व करिया को पड़ियो द रिक्वायर्ड इक्वेशन इज आमको मागिछि कोन ना एंथैल्पी ऑफ फॉर्मेशन ऑफ इथेन अर्थात इथेन इज फॉर्म फ्रॉम कार्बन एंड हाइड्रोजन so the required equation is 2C plus 3H2 gives C2H6 what is the enthalpy change for 2C the equation was 1 is multiplied by 2 and for 3H2 the equation 2 is multiplied by 3 and then by adding we get आम प्रथम इक्वेशन 1 को 2 रे मल्टीप्लाई कलु आमको मिला 2C plus 2O2 gives us 2CO2 enthalpy change is minus 787 kilojoule again equation 2 into 3 that is 3H2 plus 3 by 2 O2 gives us 3 water enthalpy change is minus 857.4 kilojoule. Now by adding we get 2C plus 3H2 plus 7 by 2 O2 gives 2CO2 plus 3 water delta H enthalpy change is minus 1644.4 kilojoule. Now by subtracting the equation 3 from the equation 4 we get equation 4 टिको हम प्रथम लिखिदेलु 2C plus 3H2 7 by 2O2 gives us 2CO2 plus 2 water enthalpy change is minus 1644.4 kilojoule equation 3 हमको given थिला C2H6 plus 7 by 2O2 gives 2CO2 plus 3 water enthalpy change it minus 1560 kilojoule. Now by subtracting we get 2C plus 3H2 gives us C2H6 enthalpy change is minus 84.4 kilojoule. Thus the enthalpy of formation of ethane is minus 84.4 kilojoule. Now let us come for the next group. Welcome to all of you to the group D, that is the descriptive section covering the 5 marks questions. Here one question is to be answered out of 2. Each question requires not more than 12.5 minutes to write the answer. ये 5 मार्क प्रश्न पाई आमे मैक्सिमम 12.5 मिनिट समय दे पारिबो जाफर आमे 45 मिनिट को शुरू करे सब प्रश्न 45 मिनिट रे सब प्रश्न उत्तर दे पारिबो. Let us come for the question number 1. Write a note on Hess's law or एमती भी प्रश्न आसी पारे स्टेट एंड एक्सप्लेन हेसेस लॉ राइट इट्स एप्लीकेशन. वर्तमान आम हेसेस लॉ कथा लिखा व्हाट इज द स्टेटमेंट ऑफ हेसेस लॉ अकॉर्डिंग टू G.H. Hess it may be noted that the total enthalpy change heat evolve or absorb in a particular reaction is always same whether the reaction takes place in one step or in a number of steps. In how many steps the reaction is carried out it doesn't matter, but the total enthalpy change remains the same. Description. Suppose in a reaction A changes to D in one step, but let there the same reaction carried out in 3 steps, such as A to B, B to C, C to D, accompanied with the enthalpy change delta H1, delta H2, and delta H3 respectively. याक हमें डायग्राम हिसाब से देखिए तो let delta H is the enthalpy change when the reaction takes place from A to D. Thus path 1 A directly changes to D with enthalpy change delta H, and path 2 A changes to D in 3 different steps A to B, B to C, and C to D with enthalpy change delta H1, delta H2, and delta H3 respectively. So according to Hess's law, the total enthalpy change in path 1 must be equal to the total enthalpy change in path 2. That is delta H is equal to delta H1 plus delta H2 plus delta H3. Justification. If Hess's law is not correct, then either delta H may be greater than delta H1, delta H2 plus delta H3, or delta H may be less than delta H1 plus delta H2 plus delta H3. So what happens? Now in these two cases, there are case 1 delta H is greater than delta H1 plus delta H2 plus delta H3. So what happens? Here, the delta H minus delta H1 plus delta H2 plus delta H3 is positive. In case of case 2, for delta H is less than the sum of delta H1 plus delta H2 plus delta H3, then delta H minus the sum of delta H1 plus delta H2 plus delta H3 is negative. So both the cases goes against first law of thermodynamics. according to which energy can neither be created nor it be destroyed. So আমি যা মনে করি যে ভুল অটে অর্থাৎ ডেল্টা is equal to the sum of delta H1 plus delta H2 plus delta H3. Now examples. আমি ଗୋଟେ example নেবা, let us consider the formation of carbon dioxide from carbon and oxygen. Carbon converted to carbon dioxide in two ways. Carbon in path 1, carbon can directly burn in oxygen to give CO2 with enthalpy change minus 393.5 kilojoule. In path 2, carbon burns with insufficient oxygen to give CO with enthalpy change minus 110.5 kilojoule. Again, carbon monoxide burns in oxygen to give CO2 with enthalpy change minus 283.5 kilojoule. In case of path 2, if these two reactions are added, then we will get C plus O2 gives us CO2. Enthalpy change is minus 393.5 kilojoule. Thus, delta H is equal to delta H1 plus delta H2. Now, let us come to the question application of SS law. For SS law is applicable for determine the heat of formation, for determine the enthalpy of transition, and for determine the enthalpy of various reaction, or for predicting the enthalpy of various reaction. Now for the question 2 of group D. What is entropy? Write down its characteristics, describe the different factors affecting it. Let us know what is entropy. I mean entropy or randomness kahaku kaiba. Entropy is defined as the thermodynamic property of a system which measures the degree of disorderness or randomness of the constituent particle of the system. It is represented by the symbol S. Characteristics of entropy: it is an extensive property. It is a state function because its value depends upon the initial and final state only. Again, the absolute value of entropy cannot be calculated or evaluated, but the change in entropy delta S can be calculated as follows. Delta S is equal to SF minus SI. For a reversible isothermal process, delta S is equal to Q reversible by T, where Q reversible is the amount of heat absorbed or evolved at temperature T in a reversible isothermal process. If heat is absorbed, then entropy increases, that is delta S is positive. If heat is evolved, then entropy decreases, that is delta S is negative. If delta S is positive, then the process is spontaneous. If delta S is negative, the process is non-spontaneous. If delta S is equal to 0, then the process is in a state of equilibrium. Factors affecting entropy. Physical state. Entropy is maximum in case of gas and minimum in solid. So the randomness or entropy increases from solid to gas state, as entropy of solid less than entropy of the liquid less than entropy of the gas. Now second factor, temperature. On increasing the temperature, the kinetic energy of the molecules increases, hence the randomness, if the degree of disorders increases, and the entropy increases. Let us come to the third factor, chemical decomposition. As a result of chemical decomposition or ionization, randomness increases, hence the entropy also increases. Units of entropy change. In CGS unit, the unit of entropy is calorie per Kelvin per mole. In SI system, the unit is joules per Kelvin per mole. Thanks for watching Bhopal Sir's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.